Good afternoon, students. Yesterday I gave you a question as a homework in maxima and minima. So first we have to discuss that question. The question was, there was a function fx equal to 2x cube minus 3x square plus 1, and there was another function gx equal to maximum of f of t, where t is actually between 0 and x is between 0 and 2, and there is another function x square plus 3x plus 7 for gx, which is between x 2 to 3. So you have to discuss continuity in the interval 0 comma 3. Again, as I said, you have to use maxima and minima in order to solve this question. Firstly, we will differentiate this function. This would become f dash of x, that would become 6x minus 6x again. And when we equate this derivative to 0, minus 6x square minus 6x. And when we equate it to 0, we get x is either 0 or 1. So these two are the critical points. And now at x equal to 0 and 1, we have to find the value of double derivative. So when we differentiate it once again, we get it as 12x minus 6. So f double dash of 0 would become minus 6 and f double dash of 1 would become 6 actually. This is negative and this is positive. So double derivative is negative, which means 0 is the point of maxima. And when we say that double derivative is positive, that means 1 is point of minima. Now this maxima and minima part is actually helping us to find out the function here. So actually the function is given as max of function of t, and you have to find g of x. So how do we find g of x? As we did in application of derivatives as well and continuity differentiability, g of x can be redefined like this, because this f of t is actually between 0 to 2, x between 0 to 2, and t is between 0 to x. So if you remember what we studied earlier, this ft graph is actually first its maxima is at 0. So this value is at 0, then it is decreasing. At 0, this is actually f of x, and then it is coming to 1, and there it is minima. This at 1, this function is minima. I am talking about this function fx. So this function fx is maxima at 0, then it is minima at 1. And then beyond 0, we are not going on the left part because our interval is 0 to 3. And then after 1, obviously it would increase because this is a minima point, like this. So the range in which we have to consider maximum of ft is between x between 0 to 2. So is there any other point between 1 and 2 where the value is becoming equal to the value at 0? We have to consider that point. So what we see that value at 0 of this function is actually 1 when we put x equal to 0. We equate this function 2x cube minus 3x square plus 1 to 1, and we get x square as common, and 2x minus 3 would be equal to 0, which means x is either 0 or x equal to 3 by 2. So the same value 1 can be obtained at 3 by 2 also. 0 we already got, at 0 we have the value. So this is again at 3 by 2. This function is having the same value as at 1, and this is the value 2 at which the function is further more. Now if you want to write this gx, how do you write it? You write it like this, that from 0 to 3 by 2, if x is from 0 to 3 by 2, then what happens? This value, which is the value at 0, is the maximum value. From here till here, this is the maximum. As we flow from t from 0 to 3 by 2. So we say the maximum value, which is actually f of 0, and that f of 0 is 1. So we generally write it like this. From 3 by 2 to 2. Let us include 3 by 2 anywhere. So we include it here. 3 by 2 to this part of the graph, the maxima is actually the graph itself, because this part was maxima till here. Now when you go further than more than this value, then the graph itself. So you will just copy the function 2x cube minus 3x square plus 1. And then from 2 to 3, the function is x square plus 3x plus 7. So this is 2 to 3. So this is what we are getting gx. So by maxima minima, we have been able to find out the gx function. Earlier it was given in term of maximum of ft, and there were two variables, t as well as x, and t was varying depending upon x. So we have found out by the help of maxima and minima that where the maximum value is possible and how can we rewrite the function. Now what we do, we come to again continuity part. As we know, in this gx function we have to find the continuity of the function. What we do, the points which are doubtful points are 3 by 2. So at 3 by 2, left hand limit is 1 of the function. G of 1 minus is actually 1. And what would happen to g of 1 plus? So you know ki g of 3 by 2 minus and g of 3 by 2 plus. So 3 by 2 minus is 1 and 3 by 2 plus you have to find out. So if you put 3 by 2 in this function, which is actually 27 upon 4 minus 27 upon 4 again plus 1, that would become 1. So you say that it is continuous at 3 by 2. But another point you have to find it at 2. So f of 2 minus, you will see f of 2 minus, it would become 16 minus 12, 4 plus 1, 5. And f of 2 plus what you get? F of 2 you get 4 plus 7, 11, and plus 6, that would be 17. So you know ki f of 2 minus is not equal to f of 2 plus. In that case, it is discontinuous at x equal to 2, but it is continuous at x equal to 3 by 2. So this was the answer of this question, homework question. Continuous at x equal to 3 by 2 and discontinuous at x equal to 2. I hope this is clear to everyone. And with this, we complete our maxima and minima. Now we are going to start a new topic, that is integration. So in integration, as you have already used it at many places in physics as well as in maths and sometimes in chemistry also. But the integration which we will go to will be in much more depth, and we will have to study it extensively more. So when we talk about integration, so the definition of integration, we deal with the definition of integration. There is a function fx, and when you say that fx integration is actually capital Fx plus a constant of integration c, that actually means that this capital Fx, when differentiated with respect to x, gives you a small fx. So anti-derivative it is also called, just opposite of derivative. So if derivative of capital Fx is small fx, then anti-derivative of small fx is capital Fx, or integration of fx is small fx, capital Fx. And this constant of integration is put in here because when you differentiate this capital Fx plus constant with respect to x, you get a small fx in any case, whatever this constant is, because derivative of constant is 0. So we take any real value of c. C is a constant having any real value. So we cannot treat it as variable. It is again a constant. The simple example which can explain this is actually a graph x square. So if you see a graph of x square, this is a graph of y equal to x square. Now what you do, you take a graph of y equal to x square plus 1. So that would shift upward by a distance 1. And similarly, you can take y equal to x square minus 1. That will shift one distance downwards. So this way you can make many graphs. But when you find the derivative of any of these graphs, you'll find it as 2x. So that means that at any point x comma, here x comma x square, here x comma x square plus 1, here x comma x square minus 1, if you take the slope, that will always be 2x. So that is actually the slope, and this is the curve. So So when you take the slope here, that is again dy by dx equal to 2x, that only depends upon the abscissa. So if you take the same abscissa everywhere, you get the same slope everywhere, twice of the abscissa. So that's why constant of integration is geometrically explained. And after knowing the definition of integration, we have to cover few parts. For example, सबसे पहले हम standard formula की list देखेंगे, list of standard formula which we generally come across, and I think that most of us know this list of standard formula. Let us start with first x की power n dx. So this would be x to the power n plus 1 upon n plus 1, and there is a condition here that n is not equal to minus 1, because if n would be minus 1 and this plus, then this would be undefined. So other than minus 1, you can take n as any real value, any real constant number, and then you can apply this formula. If you differentiate this part, you will get this function. What happens if n is minus 1? Then this is actually written as 1 by x, and then we write as ln of mod x plus c. Ln mod x means base is e. When we take a formula like this, a to the power x dx, this would become agar a ki power x by ln a, basically a is already a constant, positive constant, plus c. Again we know that this exponential function, a is greater than 0 and not equal to 1. You can mention it here, and a not equal to 1. And if you remember differentiation, derivative of a ki power x was a ki power x into ln of a. So this is just a reverse of differentiation. And then we could also specify this e ki power x dx. So that would be e ki power x, and ln of e will be 1 plus c. Next we will be having another formula, set of formula, trigonometric set of formula we have, like sin x integration, cos x integration, integration of these trigonometric functions. So we know that if we find integration of sin x, that would become minus cos x plus c, and if we take integration of cos x, that would become sin x plus c. Generally, because cos x derivative is minus sin x and sin x derivative is cos x. If we take, next we have like sec square x dx, and then we have sec x into tan x dx. So these all have come from differentiation. Sec square x dx was actually tan x plus c, if you remember that part, and sec x tan x integration would become sec x plus c, because derivative of sec x was sec x tan x. Similarly, we had a formula like this, cos sec square x dx, that was actually minus cot x plus c, and then we have a formula like cos sec x into cot x dx, that is actually minus cos sec x plus c, right? So in this manner we can remember this formula. You have to remember just minus and this minus, these two are plus, it is minus and there it is. If you know the formula for differentiation, this basic formula you already know. Then we have some other formula again, like 1 by root over 1 minus x square dx integral, that would become sine inverse x plus c, and then we have 1 by 1 plus x square dx, that is actually tan inverse x plus c. Here again we have choice, but generally we prefer sine inverse x. We can take minus cos inverse x plus c as well, because derivative of cos inverse x is actually minus root over 1 by minus 1 by root over 1 minus x square. Here we have again a choice, minus cot inverse x plus c, again derivative is having a minus sign as well. And then we have 1 by mod x root over x square minus 1 dx, that is actually sec inverse x plus c, and that can also be rewritten as minus cos sec inverse x plus c. So these are some set of standard formula which we have to know in any case. Now if we talk about theorems on integration, so there are few theorems on integration, and then I will revisit some of these formula again and ask you a question. So just remember this formula, we are dealing with theorems. So the first theorem of integration which we have to study is we are going to study theorems on integration. First theorem statement is, some of these are quite obvious statement, but still I would like to explain you by proof one or two integration. So you will have to, you will get an idea how this can be proved. So we know that we have this theorem that we have integration of a function. Let's take this is a small fx dx, and then we are differentiating it, and eventually we are getting the same function. First we are doing the integration, then we are differentiating it, and we are getting the same function. Now how can you prove this? The proof is straightforward. Let us suppose integration of a small fx dx is some other function capital Fx. Now we know by definition which we have studied that capital Fx when differentiated must give a small fx, because this is what is the definition of integration. The value which you get, you can even write c here, no problem, or you can take c as 0, that is okay, you don't have to worry about that. So capital Fx when differentiated should give a small fx. Now what you can do, what is capital Fx? Capital Fx is actually integral of a small fx dx, and derivative of this is actually small fx. So this is simply how we prove this statement. Integral and then derivative give you the same function. So we are not going to prove each and every statement. So this was just to give you an idea how we have to approach. Another statement which we have is the integrals of the same function can differ only by a constant. Of the same function can differ only by a constant. So basically when we talk about the integrals of the same function differ by a constant, we say that if we have a function fx and we are differentiating, we are integrating this function, and we are getting suppose two outputs. Let us suppose we are getting two outputs. One is f1x and another is f2x, capital F1x and capital F2x. Now the statement says that capital F1x and F2x, difference of these two functions must be a constant. It should not have a variable x in it. So this is again from the result that we have studied in the definition, that integral of small fx will give you a function plus a constant. So what happens, the constant which we get here and the constant which we get here may be different constants. So when you subtract them, you will get the variable part cancelled out, but the constant value may subtract to give you some other constant. So this is why this statement is there. So now I come to this, as I said, I will come back to this formula, this formula. Now integration of 1 by root over 1 minus x square dx we are talking about. And we are saying that integral of a small fx, this is actually small fx, is actually some capital F1x and some capital F2x. So they should differ by a constant only. We can write here let us C1, here let us C2. There is no problem with that. So is it true that they are differing by a constant? Here it is sine inverse x, here it is minus cos inverse x. So do they differ by a constant? Yes, they do differ by a constant. If you subtract them, so sine inverse x plus C1 is actually the first F1x, and minus cos inverse x plus C2 is the another F2x. When you subtract them, sine inverse x plus cos inverse x, yeah right, plus C1 minus C2. Now sine inverse x plus cos inverse x, we all know by inverse is a pi by 2. Pi by 2 plus C1 minus C2, where there is no x remaining. So this is true. Whatever value we get by any method. In integration, when you solve questions, you can solve it by various ways. So in any way you get the answer, you should get the answer which is similar to other answer. In only difference can be of a constant. If the variable is coming out in the difference, then your answer is wrong. One of the answers or both of the answers are wrong. So this you have to understand. Next, we come to some other theorems. Similar case you can apply it for this cot inverse x and tan inverse x part and sec inverse second cosec inverse x part. Now another theorem is a constant multiplied with a function when integrated, then you can take out the constant as it is outside. So if you say a of fx dx, so you can write a of integral of fx dx. You can also make another theorem, a of fx plus b of gx dx. This is a bracket and this is a bracket, can be written as a of integral of fx dx plus b of integral of gx dx. Summation can also be splitted as it is. Even subtraction is also a type of summation. You can split that as well. Another which is an important property of integration is if you have integral of fx dx as capital Fx plus constant of integration, then we call this property as a linear extension also. If x is replaced by a linear term depending upon x, like ax plus b, this is a linear term, then what happens, this becomes f of ax plus b upon a plus c. So a is not equal to 0, obviously if you take a equal to 0 this term will vanish. So this is actually the integration linear extension. So if you want to apply it in few formula, you can apply it like this. Example, integral of sec square 3x plus 5 dx. Now just now we studied some list of standard formula. Among there was formula a sec square x integral is tan x, but here it is not x, here 3x plus 5. So you will write tan of 3x plus 5 upon 3 plus c. So this is the answer. But you have to keep in mind this has to be linear. If I would have given you 3x square plus 2x minus 5, then you can't do it like this. And in integration, one more thing you have to keep in mind, that not all terms can be integrated. Though in differentiation all the functions can be differentiated, which are differentiable, but in case of integration all the functions cannot be integrated. So while solving any integration, keep this in mind that that question has come from some authentic source, otherwise its integration may not be possible. Some of the examples are like e to the power x square dx, which cannot be integrated, not possible. So there are many other examples. This is a quite famous example and used in higher studies. Next we have another example. Root 3 sin x minus cos x dx. You have to integrate this. Now again you can integrate it in two methods. Basic, both the methods are very basic, but to understand the concept, one you can do one thing, that you reduce it into one variable, one term only. So what you can do, you multiply by 2 and divide by 2. So this would become root 3 sin x minus 1 by 2 cos x dx. And here what you can do is you integrate, just apply the theorem which we studied, a times of integral of fx minus b times of integral of gx dx. Here it would come root 3 minus cos x, and here it would become minus sin x plus c. So this is what you will get as the answer. If you do it like this, 2, this is sin x and this is cos of pi by 6. So you can write it like this, sin x cos of pi by 6 minus cos x sin of pi by 6 dx. And then you can write it as 2 times of, this integration is outside, sine of x minus pi by 6 dx. Now you have to integrate only one trigonometric term, which will give you minus 2 times of cos of x minus pi by 6 plus constant of integration. And when you expand this by the formula cos of a minus b, you will get the same term as this one. This and this are same, equal. So you can do by any other one of these methods and you get the answer. Now what is the option given? If there are any options, then you have to take care that one of those forms have come. Integration using trigonometric identities. So when we sometimes do integration using trigonometric identities. So in short, I will just recap those trigonometric identities which are quite helpful in solving the questions of integration. And why those are helpful, you will understand by the nature of identity. So when we take the first one is like if it is given 2 times of sine square x by 2. So if you are getting such type of term, you can make this change, that this is 1 minus cos x. If you are getting a term like this, 2 cos square x by 2, you can write it as 1 plus cos x, as we have already studied in this in trigonometry. These are all derived formula. Cos x is cos square x by 2 minus sin square x by 2. From there we derive this formula. If you have, let's say, 2 sin a sin b, you can write it like this, 2 sin x and cos x. First let us take this one. So 2 sin x cos x you can replace as sin 2x. Again there are 2 trigonometric functions, you can reduce it into 1 trigonometric function. See, these are quite basic which you have to apply. So we are just recapitulating all those things. 2 sin a cos b can also be used. 2 sin a sin b can also be used. 2 cos a sin b can also be used, and lastly 2 cos a cos b can also be used. And reason of using these identities is that there are 2 in products. What we do by using applying the identity is we write it as sine of a plus b plus sine of a minus b. In that case integration is quite easy, because now this integral is apart from this integral you can split the addition. So sort of this integration you can do more easily. Again, integration of these parts and these parts you can do. If you remember the formula, you can just write those formula from trigonometry. So you have to do one thing, you have to change multiplication into addition. So that will make the question more easy. Next we take some example like sine 3x sine 2x dx, sine 3x sine 2x dx, integral of this you have to find. Now by the standard method which we have just now studied, you will multiply by 2 and divide by 2. You will write 2 sin a sin b is cos of a minus b minus cos of a plus b. That would become cos of a minus b would become x, minus cos of a plus b would become 5x and dx. Then you will write it like this, half sin x minus sin 5x upon 5 plus c. So this would become sin x upon 2 minus sin 5x upon 10 plus c. So this is how you get these formulas applied. Similarly, you can write this question as a homework. You can do it. Cos x, cos 2x, cos 3x dx, integral of this. So again, you can take any 2 functions, preferably we take cos x and cos 3x, and we write it as cos x, cos 3x and cos 2x dx, and multiply with 2, divide with 2. So 2 cos a cos b, again the formula will become cos of a plus b plus cos of a minus b. So half cos of a plus b 4x plus cos of a minus b 2x, and then again 2x. So there in this step there were 3 terms which were getting multiplied. Now there would be 2 terms which are getting multiplied. Actually this would become half of cos 4x dx, cos 4x into this cos 2x dx plus half of cos square 2x dx. Now what you will do, again multiply by 2 and 2 here, and 2 cos a cos b would be applied. Here 2 cos square theta would become 1 plus cos 2 theta, right? So you will just calculate those part as a homework. So I think you understand how trigonometric identities. So we come to next example, fifth example. In this dx by 4 cos x plus 3 sin x, this is we have to calculate. Again here you have to again go to trigonometric part. In such question, a cos theta plus b sin theta, what we used to do, divide and multiply by root over a square plus b square. So if you see a square plus b square under root, that is actually 5. So next step what you will do, you will multiply by 5 and divide by 5. This would become 4 by 5 cos x plus 3 by 5 sin x. And next you can even in this case is you know what is 3 by 5. This is actually either you write it as sin 37 degree or cos 53 degree. But if in such case you don't know, so what you will assume? You will assume this as cos theta, this as sin theta. So 3 by 5 is actually cos theta and 4 by 5 is actually sin theta. So tan theta would become 4 by and theta would become tan inverse of 4 by 3. So this is the part which we all know. And next what you will do, this would become dx upon 4 by 5 sin theta and 3 by 5 cos theta sine of theta plus x. So reciprocal of this would become cosec of theta plus x, and then cosec of theta plus x. You don't know the formula for cosec of theta plus x, right? Right now we have not studied. So what we can do here, we can do some manipulation. What type of manipulation we can do here is we divide and multiply by, or no, cosec theta plus x, you can write the formula. No, yeah, you can write the formula. There is no need of doing any manipulation here. So you can write it like this, 1 by 5, and cosec theta plus x formula was log of, right now I haven't told you cosec of theta plus x. Fine. So actually there is a formula which we will study later on, but right now I'm just applying this formula. And if you want to understand how this formula I'm applying, so one thing you can do is 1 by sin theta plus x dx can be written as, just write it like this, cos of theta plus x in the denominator and in the numerator. You can do like that. So this would become tan of theta plus x, and this would become sec of theta plus x dx. And next thing what you can do is, I think you should apply the formula first, then later on I will explain this how this formula has come. So I won't explain it right now. That would be another part which we have to study later on. Right now I will just explain you the result, write you the result. This is actually 1 by 5 log of mod of cot theta plus x minus cosec theta plus x. Actually reverse way you can understand this. Reverse way how you can understand this is, you differentiate this part. So when you differentiate this part, you will get this. Actually if I would have gone into this process, we have been astray in another domain. So right now we have to concentrate what we are doing. When you will differentiate this, this will become 1 by cot of theta plus x minus cosec theta plus x mod, and cot theta plus x, you remember, I hope, that was actually minus cosec square theta plus x. Okay, and cot theta plus x would become, this is cot theta, cosec theta plus x would be minus of cot theta plus x into cosec theta plus x. So if you take out cosec theta plus x as common here, so what you will get, cosec theta plus x as common, and rest would be cot theta plus x minus cosec theta plus x, which will actually cancel out with this denominator, and you get cosec of theta plus x. So you can remember this formula for now, that integration of cosec x dx, this is a formula which we'll deal later on, but it happens sometime that in integration, when you are going to solve initially few questions, you may come across many formula which you will going to learn later on, because these are all interdependent. So what you can do right now, just learn this formula. So cosec x integral is actually ln of mod of cot x minus cosec x plus c, that is plus c part. We'll come across this formula again. Now this is our answer. Now you can put theta as tan inverse 4/3. You can simplify that further depending upon the answer in which you have to obtain it. So you can further simplify that, it's okay. What I wanted to tell you was that in such type of trigonometric integration, you may have to apply the concept of a cos theta plus b sin theta by dividing by root over a square plus b square and multiplying by root over a square plus b square. Then this actually changes into one trigonometric form, which we want to do actually, instead of two trigonometric forms in the denominator with addition or multiplication would have been easier here, but in addition it is difficult. Now we come to integration by substitution. So these all the things which we have done till now, these are just the initiation of integration, in which we just want to realize that how different integrands and integration has been done. Now there are specific categories into which type of questions has been divided, like integration by substitution, by parts, exponential and logarithmic integration, trigonometric integration, then in partial fractions and many other type, then reduction formula, all those parts. So we will deal each of these parts one by one after having some understanding of how to apply the integration in questions. So we start by integration by substitution. So in integration by substitution, again based on the type of questions which we come across, we have divided it into three parts, and those parts are basically written like this. Integration by substitution can be divided into three parts: direct substitution, indirect substitution, and a standard substitution. Some of the standard substitution are there which we can directly remember them and we can substitute. So let us first do direct substitution. So in direct substitution, integral of fx dx is given as gx plus c. So now this integral of fx dx is gx plus c. If we come across any function of this sort, integral of fx, instead of fx it is f of h of x, but instead of x we are taking again a function h of x, and outside there is derivative of hx, and then we have to integrate this. So what we do, we write it as g of hx plus c. If the question is in this form and we know the integration of this, we can write it like this. Let us take an example which you will remember as a formula later on. Integral of cot x dx. Now we don't know the integral of cot x as well, just as we didn't know the integral of cosec x. There we use the formula. Here similarly the case is we don't know the integration of cot x. What we can do, we can write cot x as cos x by sin x. And then what we do, we are doing direct substitution. We see that if you integrate, in rough you can write it, if you integrate 1 by x dx, what you get? Log of mod x plus c. Now can this and this theory can be combined to integrate that. So what you can do, you can write sin x, let sin x is equal to t. this is actually a substitution, but this is why we call it as integration by substitution. Sin x is t, then when you differentiate sin x, you get cos x, and cos x dx is actually dt. So what you do, you write in the next step, this is actually numerator is dt and denominator is t. And then you can say that integral of this is actually log of mod t plus c, which is actually log of mod of sin x plus c. I hope it is clear to everyone. No? So you can remember this as a formula again, that integral of cot x is actually log of mod of sin x plus c. There is another formula, log integral of tan x dx. You can derive this formula as a homework. Similar, exactly similar pattern. That is log of mod of sec x plus c. So this is how we do direct substitution. Next we have some of the questions based on standard substitution. So some of the standard substitution which we come across. Standard substitution number 1, number 2, 3, 4. These are some of the standard substitutions. So first is actually if it is given of the form x square plus a square or root over x square plus a square, what you have to substitute is x equal to a tan theta. Mostly this is what we do. If you have, you can understand why we are doing this, because after putting x equal to a tan theta, you get a common, a square as common here, and you get tan square theta plus 1 as sec square theta, which is actually one integrand. Then it would be easier to solve. If you have x square minus a square or root over x square minus a square, then x equal to a sec theta. Here again we have choice. We can take a cot theta here as well, and we can take a cosec theta here as well, but generally we take tan theta and sec theta, because again when we differentiate cot theta, you will get a minus sign. You will get minus sign in cosec theta as well. So we generally take tan and sec. But depending on the question, we can take like this as well. We have another a square minus x square root over a square minus x square as x equal to a sin theta, or you can put as a cos theta. Again a sin theta generally we take. We have another one, if we have root over a plus x or root over a minus x. Now here there is no square. So what substitution we need to do here is x equal to a into 1 plus cos theta actually we want to make now. So what we prove a cos theta. This is what we can do, or you can put a cos 2 theta. Anyway, there is no boundation. You can take 1 plus cos 2 theta, then here it will become sin square, and there here will become cos square theta, and here 1 minus cos 2 theta will become sin square theta, and root will get cancelled. Now there are some other examples where also we remember some of the standard substitution, but first I am giving those examples, then I am giving you the statement from which you will relate that how that statement is applied to that example. Because if I write the statement first in those questions, you won't understand those statements. Here you quite understand these statements because these are common terms. Now I am giving you an example. This example is integral of dx upon x plus 3 to the power 15 upon 16 into x minus 4 to the power 17 upon 16. Now right now we don't know any formula for this, how to apply and what are the method to do this. So first I will do this question. So when we will apply some of manipulation here, we can do one thing. Here we write this statement like this: dx upon x plus 3 upon x minus 4 to the power 15 by 16. This is what I am doing. Now x plus 3 is already 15 by 16. I am dividing by x minus 4 to the power 15 by 16. So we have to multiply x minus 4 to the power 15 by 16 here. This would become 15 by 16 plus 17 by 16. That would become 32 by 16. That is actually 2. So next, this part is actually x minus 4 to the power 2. Now what you have to do is, you have to take this as t. X plus 3 by x minus 4 as t. Now when you differentiate this, you get x minus 4 whole square as quotient rule, x minus 4 into 1 minus x minus 3 into 1 equal to dt upon dx. Now this x and this x would cancel, minus 4 and plus 3 would become minus 1. So this would become minus 1 upon x minus 4 square dx equal to dt. So this integration actually reduces to I equal to minus of integral of dt upon t to the power 15 upon 16. This is what you can write it like, and then the integration is quite easy. T to the power minus 15 by 16 and x की power n का formula लगा के x की power n plus 1 by n plus 1 plus constant. So the form this would become t की power minus 15 by 16 integral dt minus plus 1 t to the power 1 by 16 upon 1 by 16 plus c. Now you can replace t as what you assumed, x plus 3 by x minus 4. So we get the final answer. I think it's okay with everyone. यहाँ पे x plus 3 है. So here it is x plus 3 not minus 3. So this value is coming out to be minus 7. So it's you have to just keep in mind that it is actually minus 7, and here is actually minus 7 in denominator, and here is actually minus 7 in denominator. Here it is minus 7 in denominator. So answer is actually minus 16 by 7 t to the power 1 by 16 plus c. So this calculation part you have to look sometimes, relook sometimes. And next, the statement which I am concerned with in this case is, if we have a statement like this. Now I am writing you the statement. What we have done in this question is, we have seen that the integrand, this integrand was of the form of 1 by x minus a to the power 1 minus 1 by n and x minus b to the power 1 plus 1 by n. If you observe, this is what the integrand form was. If you see, 1 n is actually not 1 and n is a natural number. If it would be 1, then this would vanish. So n is not 1 and n is a natural number. So if you see, here it is actually 16. 1 minus 1 by 16 is 15 by 16, and 1 plus 1 by 16 is actually 17 by 16. So if you see, this form was matching with this form. And if this form integration you have to do, there is a sort of tip or trick, whatever you call it, technique to solve this, that you take x minus a by x minus b as t. This is what we have done here. And before doing this, what we do generally, that we divide by x minus b to the power 1 minus 1 by n, and we multiply with that. So this will become automatically square, because plus 1 by n minus 1 by n will cancel. So this is the process for solving this type of questions. Next, again, some other formula we could come across. So I'm doing another question. So this is again among the list of those 4 points which I wrote for standard substitution. This is actually 5th, and then there would be a 6th also, which you will come across after solving this question. It is given as dx upon x plus root over x square minus 4 whole to the power 5 by 3. So in order to solve this question, what we do, we assume the inside value of this 5/3 is actually t. So this is the statement as well, which I will write finally. So right now just see, when we write it like this, x plus root over x square minus 4 equal to t, and differentiate it, what will happen? 1 plus root over x square minus 4, and this would become x, and this would become dx equal to dt. 2 actually get cancelled when you differentiate it, and this would become root over x square minus 4 plus x by root over x square minus 4 dx equal to dt. Now root over x square minus 4 plus x is already t, so you can write it as dx upon root over x square minus 4 equal to dt upon t. We divide this with this, t would go there. Next, what you will do, when you will try to substitute every x with t, you will come across a problem here. Like when you will write this integration as, in denominator you will write it t to the power 5/3, and when you dx, so that is dt by t, it's okay, no problem. But there is a term root over x square minus 4 as well. That means if you have to multiply with root over x square minus 4, so this is actually posing some problem, because this is not independent of x. This has to be reduced into t. So what we do, we again come to this substitution we have made, and we write it like this: root over x square minus 4 equal to t minus x. Square both the sides. X square minus 4 equal to t square plus x square minus 2tx. Cancel x square. You will get x equal to t square plus 4 upon 2t. Now you can substitute this x here. So when you substitute, root over x square minus 4 would become t square plus 4 whole square minus 4 and this 2t. So this would become 4t square root by 2t. I hope this all is this everything of this clear na to everyone. This is standard calculation which we are doing, and then this would become t power 4 plus 16 plus 8t square, and here it is 16t square. So that would become minus 8t square, and that would become actually a minus b whole square. This calculation you will do, and root and square will cancel. You will get in numerator t square minus 4 upon 2t. This numerator part will become t square minus 4 whole square and under root. So that would become t square minus 4. And then you will take this root over x square minus 4, the value here. So in the next step, you will write this as root over x square minus 4 is actually t square minus 4 upon 2t. That would become 2t square, and t to the power 5/3. That would become 11/3 dt. T square and 6 plus, it's okay. And then you will, this is t, not 2, and 2 is outside. It's okay. Now you can calculate. No, it's okay. You can separate this LCM. T square by t ki power 11/3 simply x ki power n dx integration, and this divided by this, and then you will substitute back what you assume t as x square minus 4 under root plus x. Now there is a statement. That statement says that if you have some of this type of term, just say as we wrote there, like x plus minus root over x square plus minus, let's take a square to the power n. This is what we had this form. So always express the term. Now this n is not a natural number. It can be a natural number. It can be a fraction, as there was a fraction 5/3. So express the term inside the bracket as t, and then proceed. So you would be able to solve such type of question in this manner. So this is actually the 6th type of standard substitution which we generally do. Now there is another one which is actually indirect substitution. Indirect substitution basically it is difficult to find a proper substitute in indirect substitution. That's why we call it indirect. We have to do a lot of mental work in order to find out, but we have to substitute. So in those cases, we start with the example. First example is x upon root over 4 minus x square dx integral. Now this can be substituted. This is what we have. Now there is a root here also. Otherwise it was an easy question. If there was not a root here, then 4 minus x square is t and derivative is actually minus 2x dx, that is dt. X is present in the denominator. The difficult part is that when you take root in the numerator as well. So in that case, that won't be a direct substitution. So you have to do a lot of manipulation. X to the power 1 by 2 you write first, 4 minus x square under root dx. Now what generally our approach in such questions are that the numerator part is x to the power 1 by 2. How do we get x to the power 1 by 2 as a derivative? Because this is multiplied with derivative. So generally we take x to the power 3 by 2 whose derivative is x to the power 1 by 2 with a constant multiplied. So let us assume that x to the power 3 by 2 is t. Actually directly there is nothing called x to the power 3 by 2 in the question. But indirectly we are assuming that x to the power 3 by 2 is t. After assuming this question becomes like this. 3 by 2 root over x dx equal to dt. And then root over x dx would become 2 by 3 dt. And this would become root over 4 minus x square will become, if you see x under root is x square, if you want to find it from here, x cube is actually t square, and if you want to find x square, then it is t to the power 2 by 3, that is 4 by 3, na? This is actually 4 by 3. X square is t to the power 4 by 3. So now, okay, no problem. So x square is coming out to be t to the power 4 by 3. If you put it here, t to the power 4 by 3, like this, would you be able to solve this question? There is nothing in terms of t outside. It will come outside 2 by 3. There is 4 minus t to the power 4 by 3. This integration is not possible. This integration is not possible because the question which has been given is not correct. You can just verify that when you have done this substitution, you have got t to the power 4 by 3. Obviously you cannot integrate it because either this has to be t square or t. Otherwise there should be some term of t multiplied over here. So there was problem with the question, and the correct question was, here it is not x square, here it is x cube. It is okay. So you can identify wrong question as well. This would become x cube and this would become x cube equal to, next you can write x cube equal to t square directly, and then when x cube will actually t square, so this would become t square. Then this would become 2 by 3, and integral of this is actually again a formula which we will study. Actually we have studied this formula, na? 1 by root over 1 minus x square dx integral is actually sine inverse x plus c. There is a formula 1 by root over a square minus x square is equal to sine inverse x by a plus c. So there is actually, instead of x, there is x by a. So here you will write sine inverse t by 2. So this would become 2 by 3, and then t you can put it as x to the power 3 by 2 and get the answer. So there was a, you can identify where the problem is even if there is a wrong question with you. And we didn't use this x cube or x square or x whatever here it was. The purpose of taking x to the power 3 by 2 was as t, just remember, was this root over x in the numerator. This root over x gave us the idea that if we want this as a derivative, we should take x to the power 3 by 2. And then automatically question must be framed like this, that after taking x ki power 3 by 2, this must be solvable. If it is not solvable, then that means question is incorrect. We take another example. So this is first example of indirect substitution. Another example which I will write of a little bit of trigonometric functions involved in it. Integral of cos x minus sin x 3 plus 4 sin 2x dx. This is what you have to find. Now again यहाँ पे direct substitution is quite not obvious. Okay, you cannot directly substitute anything like sin x or cos x or something like that. So again you have to think something. How will you think? There are two terms which are multiplied in the numerator. Denominator is not present here, it is 1. So this could be a derivative of some function, or this could be a derivative of some function. Taking this as a derivative of some function is actually sort of not an appealing thing, because 3 is a derivative of some function, is quite not digestible. And if you want to find out the derivative, this as a derivative of some function, then what you can do, cos x minus sin x integral, just find out integral of this part, cos x minus sin x. So this would give you sin x plus cos x. That is actually derivative of this will be this. This is what we have. Now what we do, that if you take this sin x plus cos x as t, let us assume this is as t, and then what we do, we put cos x minus sin x into dx as dt, because cos x minus sin x is actually derivative of this t which we have assumed. Now rest part is this. This is how we have to substitute. Now it is sin 2x has to be obtained from sin x plus cos x. So if you square both the sides, then what will happen? T square will be equal to sin square x plus cos square x, that would be 1, plus 2 sin x cos x, that will be sin 2x. So you got sin 2x is t square minus 1. Then you can put that sin 2x here. So this would become 3 plus 4, and this would become sin 2x is t square minus 1. That would become integral of 4t square minus 1 dt, and then this question has been solved. So you have to see indirect substitution in this manner. You have to find out a derivative, and then you have to find out a proper derivative. Another example. X square plus 4 upon x square x की power 4 plus 16. Now this question actually also called not mathematical or in theory books, but in some of the question solving packages and books, you can see that this type of question is called a special integral. So this is a special integral, and this set of questions can be, you can deal some this type of questions with some standard method. So what you observe here is there is a quadratic term in the numerator, and then we have a 4-degree term in the denominator. So if you see this is x ki power 4 plus 16, and this is x square plus 4. Now in this case you have to do one step which will be applied to every such question. So you divide by x square in the numerator, and you divide by x square in the denominator. So this is what we will get. And if you see this part as a derivative, So this part is actually a derivative of x. Again, indirect substitution is there. This part is a derivative of x. 1 is derivative of x. And 4 by x square is actually derivative of minus 4 by x. Because if you differentiate this part, you'll get plus 4 by x square. So this x minus 4 by x derivative is present here, which you can assume as t. Now after assuming this part as t, the numerator part has been solved, that is actually dt. Now you have to worry about the denominator part, because this is 1 plus 4 upon x square dx equal to dt. And then we have x square plus 16 by x square, which can be written as x minus 4 by x whole square. That is x square plus 16 by x square we get from here. But one more term we get, that we get as minus 8. So what you have to do, you do have to add 8 here in order to make this term and this term as equal term. Now this term is actually integral of dt upon x minus 4 by x is t. So this is actually t square plus 8. And then integral of this is, again we studied this formula, 1 by 1 plus x square dx equal to tan inverse of x. And we can write a similar formula, 1 by a square plus x square dx equal to 1 by a tan inverse of x by a plus c. We will come across the derivative of this formula, how we derive this formula. So 1 by a tan inverse of x by a plus c. So this would become 1 by root over 8 tan inverse of t by root over 8 plus c. And then you can substitute t as x minus 4 by x. I hope it is okay with everyone now. Okay. Now we take one more example, or you can write this example as a homework. We move further. This example which I am giving now, you can take it as homework. X square minus 1 upon x की power 4 plus x square plus 1 dx. So in this problem also you have to approach it similarly. You will divide by x square in the numerator and x square in the denominator. Take 1 minus 1 by x square as derivative of some function, and that function would become obviously 1 plus 1 by x, x plus 1 by x, and make this as a perfect square of x plus 1 by x. That is the standard method which we have to do in such type of questions. So now we move on to algebraic integrals. Some of the algebraic integrals formula we have come across at various places right now. So when we were studying, we studied that first of all we come across cosec x dx integral. That is actually trigonometric, but its derivation comes from algebraic in some manner. So then we come across this tan in 1 by a square plus x square dx integral, and then some other formula. So all of those formula can be formed or can be solved by some set of formula or some approach which we term as algebraic integrals. Now you have to remember actually each and every formula of integration, then only you would be able to solve the questions of integration in any form. Otherwise there is a major problem with students is that they get confused in solving questions, that which formula to apply and which formula not to apply, generally because they don't remember those formula. If you remember those formula, each and every one strongly, then there won't be any problem. Algebraic integrals. So again these set of formula are again very important as the standard formula, and you have to remember all of these formula, however difficult they seem. So we first write dx upon x square plus a square equal to 1 by a tan inverse x by a, which we have written just now. So when we want to derive this formula, we are not going to derive each and every formula, algebraic integrals, but some of the formula which are important, those derivation are important, those will derive. So when you approach for this formula, you will do like this: dx upon x square plus a square equal to, and I already told you this is a standard substitution, and here what you do, you write x equal to a tan theta. So when you write x equal to a tan theta, this will become a square tan square theta plus a square, as we have written x equal to a tan theta. And then when you differentiate dx, you get a into sec square theta d theta. I hope it is okay with everyone. If anyone is having problem, they can ask the question. So this would become a sec square theta d theta. That would become sec square theta by a, and 1 plus tan square theta would become sec square theta d theta. These two will get cancelled, and integral of d theta is actually theta. 1 by a comes outside, and theta is nothing but x by a tan inverse of x by a plus c. So we remember this as one of the algebraic integrals, 1 by a tan inverse of x by a. Next formula is 1 by x square minus a square dx. So when you again derive this formula, you get ln of, outside there is 1 by 2a, and ln of mod of x minus a upon x plus a. So this formula is again not so difficult to derive. In this formula, we actually apply the formula of a square minus b square in the denominator and split them. So when we apply the formula of a square minus b square in the denominator, this will become 1 by x minus a into x plus a dx. And if you see these two terms, difference is actually 2a. So you can do one manipulation: 1 by 2a upon x minus a into x plus a dx. This is what you can do. And 2a can be written as, this is 2a here, and this 2a can be written as x plus a minus x minus a upon x minus a into x plus a dx. This is what you can write it as. And then you can separate them. So here x plus a would cancel, 1 by x minus a will remain, and 1 by x minus a integral is actually log of mod of x minus a. And if x minus a cancels, x plus a remains, and that is minus log of mod of x plus a plus constant of integration. And this is actually this thing. If you apply the formula of log m minus log n, that is log of m by n plus a constant you can apply here, 1 by 2. Next we have similar formula, and we are not going to derive that. Integral of 1 by a square minus x square dx, that will become 1 by 2a ln of mod of a plus x upon a minus x plus c. Instead, if you don't even need to derive it, because here we have just changed the sign of x square and a square. So when you take minus common, the integration becomes similar, and then minus that part is actually this minus this, actually x plus a by x minus a. Since it is mod, you can write it as a minus x or x minus a. There is no problem with that. There is next one which we are again not deriving. You can do it by substitution, standard substitution, which we have studied. That is dx by root over a square minus x square. It is sine inverse of x by a plus c, which we used it earlier also. So here also you will do the substitution, x equal to a sine theta, and solve it. You'll get the formula. Next standard formula is fifth one, which is actually dx by root over x square plus a square. This can be written as ln of mod of x plus root over x square plus a square. Now we have come across a formula which is a formula similar to which we came in the first instant, that was cosec theta. If you know this formula, you can derive that formula as well. So first let us derive this formula. If you differentiate this, you will get obviously this term. But in order to solve it, how will you approach? You can write it as dx upon x root over x square plus a square here. And then even you can do one thing. You can either do a standard substitution, that is x equal to a tan theta, but sometimes it gets quite lengthy with that substitution. So another thing which we can do is we will multiply and divide by root over x square plus a square, and then also we can proceed. So I hope this part I can leave for homework. You can derive this. The point which I am interested is the formula of cosec theta. How to apply this derivation, this formula in that cosec theta. So if you see that cosec theta is actually integration of cosec theta d theta is actually 1 by sin theta d theta. And if we have to apply this formula over here, and this formula, if you remember, we got like this: log of mod of cosec theta plus cot theta d theta. This was the formula. Cosec theta when differentiated give minus cosec theta into cot theta. Cot theta when differentiated give minus cosec square theta, and you get minus cosec theta as the result. So you can take minus common as well here. Now this formula and this formula we have to relate. So next step, instead of writing 1 by sin theta, one more thing you can do is write it as cosec theta. This is a manipulation which you have to do. There is no way out. You have to do this manipulation. You have to write it as cosec theta plus cot theta in the denominator and cosec theta plus cot theta in the numerator, and this is actually d theta. And then you have to do one thing: integral of cosec theta plus cot theta, and this is cosec square theta plus cosec theta cot theta d theta. And when you take a minus sign over here, you can take a minus sign here as well, and then you say that this actually becomes minus cosec theta derivative is actually minus cosec theta cot theta, and cot theta is minus cosec square theta. So this is actually derivative as dt upon t. So this is minus ln of mod t plus c, which is actually cosec theta plus cot theta you have taken as t, and you get this formula. So there is quite of manipulation here which you have to do anyhow. So let us remember this formula, and there is a similar formula here which you have to remember, and you can remember similarly. You don't have to make a different effort to remember those formula. Root over x square minus a square doesn't make any sense. You have to do a square minus x square. Integral of this is log of mod of x minus root over x square a square minus x square. You can even cross check this result. If you get confused, you just differentiate this one. You will get x minus root over a square minus x square in the denominator, and this would become 1 minus 1 by 2 root over a square minus x square, and when you differentiate it, you will get a result like this. So when you will differentiate it, you will get a result like this: x minus root over a square minus x square. This would become 1. This would become minus 1 by x square minus a square when you are saying now. So that doesn't make any sense of a different formula, because a square is a constant. Okay, and one thing is there, x square minus a square, if you want to put, let's see, we'll see that part as well. So instead of that, you can put it as minus a square here, and you can get the same formula. You don't have to apply a different effort for there. Yeah, it's okay. If you are saying that there is a x square plus a square, and x square minus a square. Actually this part I was not, this part we have already done. So I was doing extra effort to do this in a similar manner. So actually what I want to summarize right now is, there is no need of this formula. There is no such formula, because we have already did a formula, that is dx by root over a square minus x square is sine inverse x by a, right? So in the flow we just forgot that we have already done this formula. There is another formula which is actually x square minus a square. But do we need to remember this formula? Actually logically we don't need to remember this formula. If we remember x square plus a square, then in books it has been given one more formula which you have just pointed out, that another formula is dx upon root over x square minus a square, and you say that formula is ln of mod of x plus root over x square minus a square plus c. So does it make sense to remember two different formula like this? Obviously not. A square is a constant, na? You write it plus a square, you write it minus a square. Instead of a square, you write it minus a square here. So these two formulas are not two different formula. These are same formula. Yeah. What I got confused was that there is another formula somewhere which is actually this, and which we already did. So this formula is not of log, this is of sine inverse. I hope this part is clear to everyone, na? Where the link has been broken. Now we come to another one. Actually I am skipping this part derivation for the next class. As I said na, कि root over x square plus a square integration dx by root over x square plus a square, या फिर integration of dx by root over x square minus a square. So this integration I am skipping for the next class when we will study integration by parts. Here it will be solved by integration by parts. This would be derived. The formula is log of mod of x plus root over x square plus a square plus c, and log of mod of x plus root over x square minus a square. If you want to write two different formula, then I hope it is clear now. So this is one formula and derivation is by parts. So when we will study by parts, then we will derive. Right now if you want to derive, then the lengthier method is that you do x equal to a tan theta. But while solving by x equal to a tan theta, in some place you may come across by parts. So again you will get into trouble with by parts, as we have not studied. So just right now remember this formula, or remember this formula. No need to remember this formula. So I hope it is clear till now. After remembering this formula, this will be used in further three formulas which are quite important formula of algebraic integrals. And those three formula are, first one, we have done 5 formula. Na? So again we are starting from the first formula, and that first formula is root over x square plus a square dx. Now I am not writing the formula for this right now. I am first deriving it because the formula is quite lengthy. So after knowing the derivation, you can absorb the formula. Without knowing the derivation, it is quite difficult to absorb the formula. So when you will derive this formula, let us suppose this integration which you have to find is I. And then what you do, again here there is again by parts, and if you come to by parts, then it is being done by u into v integral dx. Again I have to leave it for the next class. So you take it as the first function, 1 as the second function. Actually 1 is multiplied here, which you take as a first second function, and then you integrate by parts. So these formula you have to leave it, the derivation part actually have to leave it for the next class. Right now just remember this formula. Integral of root over a square plus x square dx is x upon 2 root over a square plus x square plus a square upon 2 ln of mod of x plus root over a square plus x square plus c. This is how we write this formula. Now this is a quite lengthy formula. Like after you will know the derivation in the next class, you will be able to absorb this formula, right? But it is used in lot of questions. So you cannot skip to remember this formula. Another formula which you have to remember is integral of root over a square minus x square dx. That is actually x by 2 root over a square minus x square minus a square by 2 sine inverse x upon a plus c, right? So this is another formula. One more formula is there, root over x square minus a square, if you want to write. Again, this formula doesn't make sense in a separate manner, because minus a square, simply you will put minus a square here, you will put minus a square here, and you will put minus a square here. So actually, generally in books you will find these three formula, but if you can remember as two formula. There also two formula can be remembered as one formula. Fine. So let us come to few questions based on this formula. Now, algebraic integral could be of the various form. The form 1. This form could be of this form, dx by a quadratic in the denominator, or dx by root over quadratic in the denominator, or dx into root over quadratic in the numerator. So this is first form, and all of these forms are calculated by one specific method. That method is making perfect square. If you make perfect square of any of these, this has been solved by the formula which we have studied just now. So if you want to take an example, you can take one example like this, dx upon root over minus x square plus 4x plus 6. Now this is of the form 1, as we say that this is of this form. You will do like this, dx upon root over, this can be made a perfect square like this, minus x square taken minus as common, and then minus 4x you have to write it as, you know how to make a perfect square in quadratic equation, that would become plus 4x. Now in order to make a perfect square, this is actually 2ab, that is 2 is present here, so you have to add 2 square, that is 4 here, and then this is actually minus 4, so you have to do a plus 4, so this would become plus 10. So this would become dx upon root over 10 minus x minus 2 whole square, that is perfect square. Now this is the formula for sine inverse x by a plus c, because this is a linear extension. You know root over 1 by a square minus x square dx equal to sine inverse of x by a plus c, and here instead of x it is given as x minus 2, which is actually a linear extension. A is 1 and b is minus 2. So you will write it as sine inverse of x minus 2 upon root over 10 plus c. A is already 1, so you don't have to write anything here. If it is of this form or this form, you can solve it similarly, because you know if this could be become x square plus a square, x square minus a square minus x square, a square plus x square. In all of these cases, you know the formula. Similar is here, similar is here. So all the 6, 7 formula which we have just did just now, the x square a square combination with plus minus here and there in the numerator, in the denominator, with the root, without the root. So those formula you have to remember and apply everywhere by making it a perfect square. Next we come to integral of another form, that is form 2. In form 2, we have little bit of deviation from this form 1, and what that deviation is actually ax plus b upon cx square plus ex plus f dx, or it could be of the form ax plus b by root over cx square plus ex plus f dx, or it could be of the form ax plus b into root over cx square plus ex plus f dx. So the difference in the previous form and in this form is that in previous form there is a quadratic in denominator, or a root over quadratic in the denominator, or root over quadratic in the numerator. Here there is a linear term associated everywhere. So when we come across such questions, let us take an example like this, then we can make a theory for this as well. Evaluate 3x plus 5 upon x square plus 4x plus 3 under root. Verify. Yeah, this is the question. So when you solve such type of problem, what you have to do, you have to express the linear term in the numerator in terms of the derivative of the quadratic present anywhere, here, here, or here. So what is the derivative of this quadratic? It's 2x plus 4. So you have to write 3x plus 5 in terms of 2x plus 4. And how can you write it? You assume that this is some a constant times 2x plus 4, some plus b constant. Then this would become 2ax plus 4a plus b. And what you can do next, x coefficient is 2a, here x coefficient is 3. So a must be 3 by 2. And here constant is 5, here 4a plus b, where a is already 3 by 2. So this would become 6. 5 equal to 6 plus b, that means b equal to 5 minus 6, that is minus 1. So you can write in the next step this equation as integral of 3x plus 5 is actually a is 3 by 2, 2x plus 4 minus 1 upon root over x square plus 4x plus 3 dx. If you calculate this, you will get 3x plus 6 minus 1, 5. Now after this, your question is quite easy to solve, simply because you have either a known form or you have the form 1, which we have studied just now. Known form is that when you take it outside, 3 by 2 here, and this is 2x plus 4 upon root over x square plus 4x plus 3 dx minus dx upon root over x square plus 4x plus 3. This is what you have to calculate. So in here, this is quite easy because already you have taken derivative in the numerator of this function. So 2x plus 4 is there. If you take it as t, so this is root over t, and in the denominator it is dt, and you can integrate that. I hope it is clear. And then minus integral, this is actually form 1. You have to make it a perfect square, and then you have to find its integration by either of those formula which we already know. So this also you can do. Next is form 3. In form 3, as you can expect now, that there should be a quadratic. First we have taken none of the terms, that is actually a constant. Then we took linear, and in form 2 what we have to do is, form 3 what we have to do is, we take like ax square plus bx plus c upon root over dx square plus ex plus f dx. And you can also make this root in the numerator. You can also do one more thing, that this can be deprived of the square root. You can make 3 forms out of this form, na? Ax square plus bx plus c upon only dx square plus ex plus f. And one more thing, you can multiply this square root. Why we are not taking without a square root in the multiplication? Because there is no form in that. There is a very simple case. We will take without a square root in the multiplication in either of those forms. That will be simply done by x ki power n plus 1 by n plus 1. Okay, that is a natural power. So here again you can do one thing. Ax square plus bx plus c can now be expressed as some constant a into this square term, a dx square plus ex plus f, plus b into derivative of this, that is actually 2dx plus e, which we did in form 2 as well, plus a constant c. This capital ABC we don't know, but we can find out by equating coefficient of x square, by equating coefficient of x and the constant term. There is another method to find out capital ABC, is that you can take any random value of x and make 3 equations and solve them. So we can do like that as well. So let us see this question. X square plus 4x plus 7 divided by, we have this root over x square plus x plus 1. Now this is actually form 3, as we say quadratic in the denominator and quadratic in the numerator. In the denominator it is with root. So first we write x square plus 4x plus 7 as capital A times of x square plus x plus 1 plus capital B times of 2x plus 1 plus capital C. Now there is a method that you equate x square coefficient, x coefficient and constant coefficient, find ABC. There is one more method, you put random values of x. So when you took random values of x, so best value which you can put, that you have to do solve it for, just as you put x equal to 0. If you put x equal to 0, you'll get 7. Here you will get a plus b plus c. This is what you will get. Put another value. Let's put x equal to minus 1. So this would become 1, 7, 8, minus 4, 4. And this would become minus 1 and this will 1, 2, minus 1. So a and minus b plus c. You will get another equation. You can put another value. Let's take 1. So this would become 4, 7, 11 plus 1, 12. And here it would become 1 plus 1 plus 1, 3a and plus 3b plus c. Now it is quite easy to solve 3 equations. All these 2 are quite, add them, eliminate b, a c ma aa gaya, and then similarly you can solve 3 equations to get 3 constants a, b, c. Put it here. You can express x square plus 4x plus 7 in this term plus this term plus this term, with the denominator this separated. This integration you can find, because this power and this root will cancel. Root will come in the numerator. And that formula we know, root over x square plus a square or x square minus a square or a square minus x square. They are any type of those formula. This again is a simple one, derivative in the numerator and root over some value in the denominator. And this is again known form, which we have done in the first one. I hope you can link that form 1 with form 2 as well as form 3. So similarly, if it is cubic, it is 4 degree, 5 degree. You can, in case of cubic, what you can do, you can divide by this polynomial division and you can proceed. Now I am coming to some special 5 type of integrals, algebraic integrals. So each of the questions which we are just solving to extent from where you can solve it and get the answer, you must solve it. So you will get, you will revise these things also, and you will solve it till the end, which will develop your confidence. Integrals of the form dx upon ax square plus b into root over cx plus d is type of integral, or it could be of dx upon ax plus b into root over cx plus d. These 2 forms of integral you can form by doing this substitution, that this root quantity which is inside the root, you can substitute that cx plus d as some variable t. Then similarly x you will have to substitute here also. If the question is this, then you have to substitute x here also, and you can find dx as dt. So this is another form where you have to do this substitution. The quantity inside the under root, you have to substitute that as t. If you have integral of this form, dx upon ax plus b into root over a quadratic ex square plus fx plus g. Now this is quite a question where substitution you can't think on your own. In previous one, if you don't know the theory of this application and you have been given a question like this, to some extent you can come to a conclusion that let us put cx plus d, which is actually inside the under root, as t, so that we will get rid of the value inside the under root in terms of variable. But here it is quite difficult to think, but we have to substitute. So what you have to remember here is the value which is outside the root, which is actually ax plus b, that you have to substitute, and also that is not t, that is 1 by t. This is what you have to do, and this is a very important type of question, theoretical question that you come across, that ax plus b you have to put 1 by t. Now let us see some question on this second one. First one you can obviously do it. So when we come across such type of question here, let us take this one, x square, this is quite easy one, we could take this one, okay. Integral of dx upon x plus 2 root over x square plus 4x plus 8. Now this is of the form, this one. There is a linear term, there is a quadratic term inside the root. Now don't do this mistake that substitute this as t. We have already not studied this. If you substitute this as t, this would be a greater problem, because a quadratic in x is in terms of t, then how can you express a x here? That would you have to make a formula for that discriminant, plus minus root over b square minus 4ac. So don't do that, take it as t. You have to follow this method, that x plus 2 equal to 1 by t. Right. And then when you will put this would become 1 by t, that would become t here, and this would become dx equal to minus 1 by t square dt. So this would become t, dx is minus 1 upon t square dt, right? And then you can do one thing, root over x square means 1 by t minus 2 whole square, plus 4x means 4 into 1 by t minus 2 plus 8. And in the next question, dt cancels, minus dt by root over t square you can take as LCM inside this. This will become t square comes outside and cancel with this t. This will become 1 minus 2t whole square plus 4 into 1 minus 2t. Actually this extra t you have to multiply here to make it t square in the denominator, plus 8 t square. It is okay with everyone? Now in the next step, you will simplify this. This would become dt upon root over 4t square from here, and minus 8t square plus 8t square cancels. So 4t square minus 4t and then minus 8 plus 4t, that will again cancel, plus 1 and plus 4, 5. So you will get this term, 4t square plus 5 under root, which is again integration of this part is 4 you can take outside. So this would become 1 by 2 dt upon root over t square plus 5 by 4, which will become 1 by 2, and x square plus a square formula is actually ln of mod of x plus root over x square plus 5 by 4, okay, a square. And then you can write it as one by 2. We took t as, actually we took t as x plus 2 was the linear term, na? So 1 by x plus 2. So this will become 1 by x plus, then this part you will solve on the, you will put t as 1 by x plus 2 and you can solve this part. Fine. Next we have integrals of the form ax plus b in the numerator, a linear term, dx upon cx plus e, a linear term in the denominator, and a quadratic term fx square plus gx plus h. Now in this there is a linear and quadratic. You cannot put x cx plus e as 1 by t because there is already a linear in the numerator. It is not a constant in the numerator. So in such case you have to again go to the method which we were applying in those three forms. You can do ax plus b as this capital A times 2fx, that is its derivative g, plus b. You can do it like this. So you have to take ax plus b as the derivative of this plus obviously a constant you have to take, and we can deal a question based on that. X plus 2, or you can do one more thing here. I think you can take it like this as well. That is a better option. You can take it like this, cx plus e plus b. Sorry, you change it to like this, because if you put fx square plus gx plus h as this term as a derivative of this, then what will happen? This term actually this term will pose some problem. If you take this term as a combination of this term as a constant, then you come to a like, let me give you an example, you will understand this part. This is integral of 4x plus 7 upon x plus 2 x square plus 4x plus 8 dx. Let us see this example here. In this example, why we are taking this, the linear in the numerator in terms of the linear in the denominator. This is actually linear in the numerator and this part is linear in the denominator. This part is actually quadratic in the denominator in the under root. Now I am saying that you don't have to take this linear as derivative of this plus constant, because if you take derivative of this plus constant, you can't split it because this x plus 2 is already attached with it. So if this linear was not there, then it is a good idea. But if this linear is there, in the next step you won't be able to solve it. So what you have to do instead, that take this linear as in terms of this linear. So if you take 4x plus 7 equal to a times of x plus 2 plus b, sometimes you don't have to solve for a and b. It is quite clear that this is actually, a is actually 4, and when you put a as 4, this b would be minus 1. And then what you can do, this would become integral of 4x plus 7 would become 4 into x plus 2 minus 1 upon x plus 2 into root over x square plus 4x plus 8 dx. Now you can separate the terms. Here the question is solvable because this get cancels. This becomes 4 by root over x square plus 4x plus 8 minus integral of 1 by x plus 2 into x square plus 4x plus 8 with under root dx. Now in each of the cases we have studied. This case is actually make it a perfect square, and in this case x plus 2 has to be taken as 1 by t. So both these questions can be solved now. But what we were doing earlier was actually appealing to us that let us take derivative of this here because it is a quadratic, this is a linear. But in the next step we would be stuck because then there won't be any known form. Next let us do another form of integral, algebraic integral. You can take this form as well. Integrals of the form. So when you will practice enough questions like 100 to 150 questions based on algebraic integrals, you will get to know it straightforward what to do where. Otherwise, you have to remember this formula, and you will take time sometimes to understand the approach to the question. So it all depends on the practice, and that practice will help you to minimize the time to approach that question. Ex plus f, and this would become root over gx square plus hx plus I. Right. So let us do a question based on this. This question we have. Again, after knowing this much type of forms, you will type of start guessing that what approach is appropriate. Like I am giving a question based on this form, which is actually 2x square plus 7x plus 11 upon x plus 2 root over x square plus 4x plus 8 dx. Now again, here it is a quadratic, here it is a linear, here it is a quadratic. What approach would be able to solve this question? You can't take a quadratic in terms of linear. You can't take quadratic in terms of quadratic plus its derivative plus constant, because in that case this linear will be with it, attached with it, which is not solvable. So here again, in such type of question, what you have to do, you take this quadratic as multiplication of this linear into this derivative of this quadratic plus this linear plus a constant. So if you 2x square plus 7x plus 11, you have to write it as a constant into this linear x plus 2 into derivative of this, which is like 2x plus 4 plus another constant b into this linear x plus 2, we won't take this derivative, plus constant c. So in this manner you will find ABC. So that part I am just leaving. ABC you can find it out either by equating the coefficients of x square, x and constant, or by putting random values of x. What you can get now is all the known forms. If you put this as this, x plus 2 will cancel, a will come outside, this will become 2x plus 4 upon root over x square plus 4x plus 8 plus b integral of x plus 2. When you will put these two will cancel, this again the previous form, and this would become dx by root over x square plus 4x plus 8, and then plus constant by this, which is actually x plus 2 equal to 1 by t. So plus constant dx upon linear x plus 2 into quadratic, that quadratic expression there, and then it is solvable. Again we study two more forms of integral, algebraic integral, then we can say that we are quite comfortable with every type of questions that come in algebraic integral. Next form is your x dx upon ax square plus b into root over cx square plus e. Now let us take a question for this. X dx by 2x square plus 3 into root over x square minus 1. Now here again, when you approach this question, you have to make a proper substitution here also, or you have to do a manipulation. If you take x square minus 1 as t square, then it is a solvable form. You have to take this quadratic inside that root. Actually it is not a quadratic, it is a quadratic without a linear part. X is not present. Here also x is not present. If x would have been present in these two cases, then this is a different form, then this form won't be there, and we have not studied any such form till now. Okay, we have studied linear outside, quadratic inside, or linear outside, linear inside root, and such forms. So here you have to keep in mind, here it is 2 degree term and 0 degree term, here also 2 degree term and 0 degree term. Now we do one thing, cx square plus e, let us take it as t square. In the next step, 2cx dx will be 2t dt. So in the next one, would be written as x dx. You can substitute now, right? This was this form. In this question, this would become x square minus 1 equal to t square. I hope it would be clear from here. X square minus 1 will be 2t square. That will be x dx will be dt, and this will become t, and this will 2x square plus 3 will become 2 of t square plus 1 plus 3, and then you can solve this further. And this is a linear into quadratic sort of thing, cubic and something, and you can solve this question. This is actually 2t dt, t also here also. It is much easier now. Actually 2 dx will be 2t dt, so there would be a t here also, and then you can solve this question. This is dt, tt will cancel, dt by quadratic, which is the form 1. Okay, you have to make a perfect square and then solve this one. Okay, please explain the ABC, how to find it, right? So the question we have come across right now, in which we have to find ABC, was, as I explained earlier also, we have two methods to find ABC. One method is actually by equating the coefficients. Another method is by putting the random values. So like if I did a question right now in which we got some equation, and that equation was, can anyone tell me that equation, which we wrote it as, just now we wrote it, this one, 2x square plus 7x plus 11, 2x square plus 7x plus 11 equal to a times of x plus 2 into 2x plus 4 plus b times of x plus 2 plus c. So here we have to find ABC. So method 1 is basically, you take 2 here, x square coefficient, and 2 you take x square coefficient here, which is actually x square 2 into a, plus there is no x square here and no x square here. So 2 equal to 2a, that means a equal to 1. Now next you take x coefficient, that is a 7 here. Here it is 2ax, that would become 4ax, plus here it will become 4 into x into a, again 4a. When you will multiply both of these, you will get one 4a and another 4a with x. Here you will multiply plus b. There is no c here with x. So this would give you, after putting a as 1, this would be 8. 7 minus 8 would be minus 1. So b is actually minus 1. Then you will take 11, which is constant. Here constant is 8a and plus 2b plus c. Put the values of a and b. So 8 minus 2 is 6, 11 minus 6 is 5. So c is actually 5. So in this case, you know a, b, c value, and you can write it over here and you can solve this question as we did. Another method we have is that put the random values, method 2. What are those random values? Let us put x equal to 0. That case will give you exactly same. X equal to 0, when you will put, you will get 11 here, and x equal to 0 will give you 2a into 4, that is 8a, and 2b plus c. This is another value. Let us take another value, x equal to 1. This is actually one equation in ABC. Let us take x equal to 1. So this would become 2 plus 7, that is 9 plus 11, 20. And here 3, and this would be 6, 18a plus 3b plus c. This would be another equation. And let us put x equal to minus 1. So x equal to minus 1, this would become 2 and minus 7, minus 5, 11 minus 5 would be 6, 1, 2, 2a and b plus c. This is the third equation. Now you know you have to solve 3 equations and find the value of a, b, c. And you can cross check you have got the correct answer or not. A equal to 1, b equal to minus 1, c equal to 5 should satisfy this. 8 minus 5 is 3 plus 5 is 8 minus 2, sorry. 8 minus 2 is 6, 6 plus 5 is 11, it's okay. Another one is 18 minus 3, 15 plus 5, which is 20, it is also okay. And third one is minus this 2 minus 1, 1 plus 5, that is 6, it's okay. This also give you the same set of solution, this also give you the same set of solution. In that case, you can solve to find A, B and C. So the last form I was talking about was basically cx dx by x square plus b. This part though we have done. Integrals of the form dx by integral of dx by ax square plus b root over cx square plus e. So in this type of terms, x equal to 1 by t you have to put and then proceed. I'm not doing any question for this. You can do a question. I can give it in homework. Homework is dx upon x square plus 5 into root over 2x square minus 3. So you can solve this one and get the answer. Now we have some random questions on algebraic integrals, which actually depends. We can make a theory on those questions as well, but it is better to avoid theory in those questions because you can't remember those theories. So you can do 1 or 2 random questions where you have to use your own manipulation and find it out how to solve those. So we have x to the power minus 2 by 3 into 1 plus x to the power 2 by 3 to the power minus 1 dx. Fine. Now we have to solve this one. So when we try to solve this one, the problem arises generally in such type of algebraic questions, which is quite random. None of the forms which we have studied is fit in there because it is not a power which is root or a square or something like that. So we have to get rid of the denominator of the power, which is actually in p by q form, rational form. So if you see it is 2 by 3, it is also 2 by 3. And the problem is not 2 but 3, which is in the denominator, cube root. So if we assume that x to the power 1 by 3 is some term t, or we say that x equal to t cube, then we can approach this question. So next step what you can do in this question is, after putting x equal to t cube, you can take it like this: x to the power t to the power minus 2 into 1 plus t square to the power minus 1. This would become 1 plus t square, and dx would become 3t square dt. And in the next step, you can write it like t to the power minus 2 and t to the power 2 will cancel. This 3 comes outside, 1 by 1 plus t square dt, and this would become 3 times of tan inverse of t plus c. Now you know what is t, and you substitute it over there. That is x to the power 1 by 3. You can have some other random question like this: x to the power minus 1 by 3 into 1 plus x की power 1 by 3 to the power 1 by 4 dx. This one question is again which you can do. So here the term which is again inside a irrational power, sort of rational power but p by q form, 1 by 4, and inside it 1 plus x to the power 1 by 3. What we do, in some cases you may not land up to the correct result at the first approach, but you can think about these theories like 1 plus x to the power 1 by 3 to the power 1 by 4 is t. Basically 1 plus x की power 1 by 3 is t की power 4. so that 4 and this 1 by 4 will cancel. So 1 plus x ki power 1 by 3 to the power 1 by 4 is t, that is this part is t to the power 4, and then differentiate this 1 by 3 x to the power minus 2 by 3 dx equal to 4t cube dt. This is what you will get, and this would become in the next step 1 plus x ki power 1 by 3 to the power 1 by 4, this will become a straightforward t, and dx would become 12t cube into x to the power 2 by 3 dt. And what do you mean by x ki power 2 by 3? X ki power 2 by 3, one more thing you can do, you don't have to find dx, you have to find actually x ki power minus 1 by 3 dx. So let us in the next step do x ki power minus 1 by 3 dx. So this will be 12t cube, this will be x ki power 1 by 3 dt. What is x ki power 1 by 3 is t to the power 4 minus 1, 12t cube t ki power 4 minus 1 dt. This would become 12 t to the power 7 minus t cube dt. And in the next step you can write it as 12, this term would become t ki power 7 minus t cube, and this would become dt. I hope it is clear to everyone. Fine. And then you will normally integrate it x ki power n plus 1 by n plus 1 and substitute back t as 1 plus x ki power 1 by 3 to the power 1 by 4. One more random question we can take. X ki power minus 11, integral of x ki power minus 11, 1 plus x ki power 4 dx whole to the power minus 1 by 2. Right. Now here it is quite difficult to think about the proper substitution. So what we do is this is 1 plus x ki power 4 to the power minus 1 by 2, and this is x ki power minus 11. What we have to do is to substitute 1 plus x ki power 4 as some term like t square, then our problem will be to some extent solved. But when we put 1 plus x ki power 4 as t square, what happens? We get as 4x cube dx as 2t dt. Now 4x cube dx is 2t dt, and this would become, this part would become t to the power minus 1, that would become 1 by t, and dx is actually x cube if you multiply here. So this would become x cube dx, so this would become x to the power minus 14, and x cube dx will become 1 by 2 t dt, that would become 1 by 2 t dt. I hope it is clear now. Now the problem is that this x to the power minus 14, what you will do for this, because when you will put x to the power 4 as t square minus 1, this will again come in irrational, the p by q form. So you have not got rid of p by q form. So you have to think much more here. Not directly you can get the result. You can't, in the previous question we are seeing that 1 by 2 is this, so we will do t square. So we have to do more manipulations. So what we have to do, 1 plus x ki power 4, and here it is x ki power minus 14. If we do something like this, that we put 1 plus x to the power 4 upon x ki power 4 as t. Now this is quite difficult to think unless you have done a question like this or a similar question. So this would, when differentiated, this is actually 1 by x to the power 4 plus 1 equal to t. 1 plus x to the power 4 by x to the power 4 whole square equal to t square. This is what I am trying to say. And 1 by x to the power 4 plus 1 equal to 2t dt. Here it would be This is okay. We have not differentiated till now. This is t square, and now we have to differentiate it. So this would become minus 4 by x to the power 5 dx equal to 2t dt. Is this clear? Now, when we substitute this here, what we get is 1 plus x ki power 4, and denominator we want x ki power 4. How we get x ki power 4 in the denominator is we divide by x ki power 4 and we multiply it by x ki power 4. Now x ki power 4 and square root of is x ki power 2 with a minus sign, that is x ki power minus 2. So we need to write it as x ki power minus 13. That is actually it would become x ki power minus 2 in the denominator, the minus 13. It's okay. So this is how we rewrite this. After rewriting this like this, what we do is 1 plus x ki power 4 by x ki power 4 is t square. This, as we did earlier, this we wrote as 1 by t. And next x ki power minus 13 dx we have to deal with. And x ki power minus 13 can be written as x ki power minus 8 into x ki power minus 5 dx. Now this is actually not mathematics, it is a magic. So what is going on here? But you have to remember these things. So actually x ki power minus 5 dx is actually minus t by 2 dt. From here it is actually x ki power minus 5 dx is minus t by 2 dt. So this is how you write it like this. And then x ki power minus 8 you have to substitute. Now x ki power minus 8, here 1 by x ki power 4 plus 1 is t square. So here you will write it as 1 by x ki power 4 equal to t square minus 1, which means x ki power minus 4 equal to t square minus 1, which means x ki power minus 4 equal to t square minus 1 whole square. Next you can multiply, this is minus 8, sorry, this will become t square minus 1 whole square. Then you can just divide this part and you can solve it. This will become direct answer, you will get minus half t square, or you can expand it and then get the answer. Okay, so x ki power n plus 1 by n plus 1 after expanding this. So these type of questions are quite random, which are of none of the forms, but still you have to decide some approach for these questions. So there has been theory for this, like if fraction is having odd or even, or their addition minus 2 by 2 is some number. So we don't have to go in such theories. You have to do manipulate on your own, because any type of question can come across and you can't make theory around every type of question. So let us discuss few more questions, and we can even start trigonometric integrals today. Let us start trigonometric integrals, and we will continue that trigonometric integrals in the next class as well. So as a recap of the class till now, what we can recap is sort of, we started with, if we recap it, the class, today's class, we started with the definition, with the integration. Then next what we did, we studied few theorems of integration. Few theorems were quite simple, like difference is constant of two different values of the same value, integration of the same function. And there was another theorem of linear extension, that you multiply that with 1 by a, integrand with 1 by a. Third part what we did was basically after 4 properties we come across some standard formula. Those standard formula which we already used in many other places earlier also. After that we came across few questions, and then we started doing algebraic integrals. But algebraic integrals came after 4th point, when we were doing questions of substitution, because after standard form we went to substitution, and in substitution we studied 3 type of substitution: direct, indirect and standard substitution. There were 6 formula for standard, like a square plus x square, a square minus x square. Similarly there were 2 other with the questions which I gave. You have to remember all the 6 formula for those. And direct and indirect, you have to see the questions and you have to apply according to the question. Algebraic integrals, again we have few set of formula in that. Those set of formula we studied for root over a square plus x. In between, I don't think before this we did anything. Did here like this, root over a square plus x square dx, root over a square minus x square dx. Then we have 1 by a square plus x square dx, and similarly we have other many formulas, 1 by root over a square plus x square, a square minus x square. Now in algebraic integrals we study few forms, and those forms were starting from the beginning. You have to remember each form, that is quadratic, then linear by quadratic or multiplied with quadratic, फिर quadratic by quadratic or quadratic into quadratic, all the three forms. Then we come across ax square plus b, cx square plus d, then linear, and then root over quadratic, then outside linear as well, root inside linear. So all those forms you have to remember. Then this is actually algebraic integrals you have completed. Now when we come to trigonometric, so which is again a topic which is quite extensive, but not as extensive as algebraic. Firstly, we see in trigonometric integrals, integrals of the form function of sin x as well as cos x upon में some other function of sin x as well as cos x dx, or it could be written as some mixed function of sin x and cos x dx, right? So this again, there is a standard approach that you do here, is you substitute sin x with 2 tan x by 2 upon 1 plus tan square x by 2, and cos x by 1 minus tan square x by 2 upon 1 plus tan square x by 2. So this is how we approach this type of questions, and then we solve this. There is one more method which we can do, like, but it depends upon the type of function. So depending upon the question, we can approach different methods there. So let us do one question, first by this method itself, then by the other method, which is actually question specific method. Dx upon sin x into 2 cos square x minus 1 dx. Okay. Now by standard method here, one more thing what we can do is 2 cos square minus x minus 1 and sin x, we can rewrite it as sin x as 2 tan x by 2 upon 1 plus tan square x by 2, and cos x as 1 minus tan square x by 2 upon 1 plus tan square x by 2. This is what we are doing here. This method I will just show here. I won't solve it because this method is quite lengthy to solve this question, but it will get solved. We'll come to another method for this question, which is actually question specific method. So this is dx upon sin x would become 2 tan x by 2 upon 1 plus tan square x by 2 multiplied with 2 cos square x by 2 will become 2 into 1 minus tan square x by 2 upon 1 plus tan square x by 2 whole square minus 1. And then this 1 plus tan square x by 2 goes in the numerator. So this tan square x by 2 can be written as sec square x by 2. And this one more tan square x by 2 whole square will also go in the numerator. That would become 1 plus tan square x by 2 whole square. And this would become dx in the numerator part. And here when you will multiply this 2 tan x by 2, 2 into 1 minus tan square x by 2 whole square minus 1 plus tan square x by 2 whole square. This you get as the denominator. Now when you will solve this all of this, then it is not too difficult, but it is too lengthy, because sec square x by 2 is derivative of tan x by 2, and you know if there is only tan x by 2 present everywhere, so you have to do one thing, you put tan x by 2 as t, and then you will come across a term called sec square x by 2 into half dx as dt, and then everything would come in terms of t, and then there is no root and nothing like that. You would be able to solve it, but it would be a lengthy task. So we have one more method to solve this question. That method says this function of sin x into sin x and cos x, which is actually a function like this, r of sin x cos x. Now if you put here instead of sin x minus sin x, what will happen? R of minus sin x cos x is in this function. This would become minus sin x. This would be 2 cos square x minus 1. So minus you can take outside. Rest of the term is same as r of sin x cos x. So r of minus sin x cos x in this question is same as of minus r of sin x cos x. I hope this is clear to everyone. This question, in this question particularly, this is how we can see. Now when we can see some function like this, what we can do is substitute cos x as t, the other one in which you are not applying minus sign. So which term is there in which you are not applying is cos x. So when you will put cos x as t, what you will get? You will get this expression 2t square minus 1. And what will happen to sin x? It is in the denominator, it is not in the numerator. So what you have to do, you will multiply by sin x in the numerator and denominator, and sin square x is actually 1 minus cos square x. So that is 1 minus t square. And sin x dx is actually derivative of cos x with a negative sign, so minus dt. Then this question is solvable. Now that was actually quite difficult, because first you will solve it in terms of t, then you will put tan x by 2, and then you have to change that tan x by 2 in terms of x. So that would take some of your time. Now there are other situations also, like if you get in a question r of sin x comma minus cos x equal to minus r of sin x comma cos x, as situation just opposite of this, what you will substitute there? Sin x as t. This is what. So you can make take one more homework question. dx integral of dx upon sin square x sin x plus cos x and cos x in numerator. So let us check by this. R of minus sin x comma cos x, this would become minus, and no other term will be minus. So minus can't come outside. Let us check like this. Minus cos x, this is minus, but these two are not minus. Still you can't make out this term out of that. Minus you can't take a common term. Let us put both as minus. R of minus sin x minus cos x. This is also one case. Let us put both as minus. What will happen? This would be minus, but this cannot be minus, this plus. Overall, everything would cancel out minus, minus. And this would become r of sin x comma cos x. In such situation, what substitution you can do is tan x equal to t. Put tan x equal to t. And how can you approach tan x equal to t here? If you have put tan x equal to 2, what you need is sec square x. Sec square x as the derivative of tan x. So let us take sec square x here. So for sec square x, you have to divide by sec square x. And that sec square x and this cos x also goes in the denominator, becomes sec x, one more. So that would become sec cube x. And this is actually sin square x and sin x plus cos x. We are actually rearranging this according to our substitution. In the next step, what we can do is sec square dx upon, let us multiply this sec cube x with each of the term. So this would become sine cube x into sec cube x, that is actually sine cube x by cos cube x, that is tan cube x, plus cos x and 1 sec x will cancel, and another sine square x into sec square x will become tan square x. And in the next step you can do like this, tan x is actually t, so t square plus t cube, and in the numerator dt, right? And then you can integrate this, you take t square as common, and then this is again a partial fraction part which we will do in the next class. After that actually we take it as dt upon t square into 1 plus t, and then we can do it by partial fraction, or we can do some other method as well. So right now we have to finish our class till here. So we are doing trigonometric, and we have done this form, these three basic forms we have done of trigonometric integration. So we'll continue in the next class from here. Thank you, class.